Recently, we have explored how EC2 autoscaling works, including several hands-on demonstrations. Now, a crucial question arises. How do we manage traffic to those instances that are serving our application or website? What I mean is, let's say in our cloud we have these three web servers running Nginx, a web service, and on the internet we have some users and they want to connect to our application. Now, they can connect to any of these because they're all identical. But how do they do that? How do they know where to go? So, what we really want to do is, we want to distribute the load between our instances. And for that, we have to use something called a load balancer or elastic load balancer. And the load balancer has an address and the user's computers will connect to the address of the load balancer. So, for example, everyone will connect to example.com. That is the address associated with this load balancer. And the load balancer will forward the connection to one of the web servers behind it. When another user connects, it forwards the connection to another web server and so on. That's how we distribute the load. So, we have an endpoint address that is publicly available, and then we can distribute the connections to multiple instances, and they can be in multiple availability zones. Now, if an instance fails, the load balancer will also redirect the connection. So, users will go to server 2 and 3 only because the other server has failed and cannot service the user requests. This is how we enable high availability. Now, in addition to high availability, you may have heard of fault tolerance. Fault tolerance is where we have the ability to recover in the event of something like a component failure. So, in this example, there's a computer. It has a memory, CPU, hard disk drive, and network card. And the network card has just failed as well as the hard drive. With this failure, it will cause a system outage because this system does not have redundancy built in. So, to achieve that redundancy, we could have multiple hard drives and multiple network interface cards. And in that case, if we lose one of those components, it's okay because we have fault tolerance in the system and we can continue to operate. So, in AWS, we can mix these things to work together. AWS provides a lot of fault tolerance built into their infrastructure, and we can spread the load across different availability zones so that we have fault tolerance in the availability zones because each one is one or more data centers. So, they are physically distinct from each other. And then we can distribute the high availability load to make sure that our users are constantly connected to the working instances of our application. Now, you have to think of the availability zone as a separate data center. As I said, they're actually made up of one or more data centers. So, remember that for the exam. But they are physically distinct from other availability zones and have high-speed connectivity between them. So, in this case, we can still have things like web server failures. And if that happens, the connection is dropped and redirected to another web server. If we also add EC2 auto-scaling, we get an even better solution because once a web server fails, it can be replaced by another one thanks to automatic scaling. So, we regularly use EC2 auto-scaling and load balancing together to make sure that we have the right amount of EC2 instances that we can recover in case of failures, and that we can route incoming connections on all of our instances. And in this case, user 2 ends up on web server 4. Now, of course, we have a lot of resiliency here as well at the availability zone level. So even if we lose an entire availability zone, and that has happened, sometimes connectivity to an availability zone can fail. But if you have your resources deployed in multiple availability zones, it's still operational and you can launch more instances in those AZs to make sure you have enough capacity. So now, again, our connections are being redirected. So, these are the concepts around high availability and fault tolerance and how we use the load balancer and auto-scaling together. So, in the next lesson, we'll look at the elastic load balancing service more clearly. See you next time.